right, so earlier I made the mistake of forgetting to hit record on the Zoom meeting. So the Zoom meeting didn't get recorded. So I'm just going to work through these examples in case you want to go back and look at how to work these out. So I'm going to change my pen up a little because I'm tired. It's too thick. Okay. So we want to find, so when we talk about differential equation and the rewritten kind by separating by parts, we want to take this equation and separate the x's and the y's. So this y squared plus 1, we want to move it over here with the dy, and this dx, we want to move it over here with the x, which gives us this equation here. So same thing for this. I'm going to move the x squared over, which gives us negative x squared. And then we move the dx over to get dx. So that's how all of those were done. Once we have it rewritten, we want to find the general form, or the general equation. So we're going to find the general solution of this example here by using separation. So what we want to do is, I'm going to go ahead and move the dx over first. So we get x squared plus 4 dy equals xy dx. I want to get rid of this y, so I'm going to move it to the other side by dividing, and I get x squared plus 4, whoops, and I'm going to write it as 1 over y, and then dy equals, these cancel, x dx. Now I want to move the x squared plus 4 to the other side, so we're going to go ahead and divide by x squared plus 4. So it can cancel, and then we put it over here as well. So my new equation is 1 over y dy equals x over x squared plus 4 dx. Now I have it completely separated. All my y's are separated from all my x's. So what we're going to do next is we're going to find those values using our calculator. I'm going to hit Menu, Calculus. We want to find the integral, and we're going to do 1 over y dy. That gives me natural log absolute value of y. Then we're going to do the same thing for the right side. Menu, Calculus, Integral, and we're going to do x over x squared plus 4 with respect to x, so dx. So it gives us that, and we write it over here. I'm going to write it as 1/2, and then natural log x squared plus 4. Don't forget your plus c at the end. All right, so we're pretty much almost finished. We just want to clean this up a little. I hate having, we need to have y by itself, and I hate having this natural log. So the first thing I'm going to do is I'm going to get rid of this fractions. There's 2 ways you can get rid of the fraction. You can multiply the whole thing by 2, or we can go ahead and just move it up to this exponent here, because our properties for logs tells us if there's a number multiplied in front, we can move it to the exponent, which is what I'm going to do. Now, to get rid of natural log, we're going to use e. So be careful, because on the right side here, e is being raised to the whole thing, including that c value. So on the left side, e and natural log cancel, leaving me with y Over here, e natural log cancel, leaving me with square root x squared plus 4. The 1/2 is that square root. And e to the c. This e to the c is just a constant, so that's going to be my new c value. So y equals e to the c, or just c, square root x squared plus 4. There's my general solution. A little side note, I'm going to go ahead and I'm going to show you what to do if you have the fraction and you were to do it by multiplying by 2. So if I were to do the same thing, let's say I wanted to, instead of taking this 1/2 to the exponent, I said I'm just going to get rid of this by multiplying everything by 2. That's perfectly fine. You can do that. If we multiply everything by 2, we get 2 ln equals natural log x squared plus 4 plus 2 times c is still going to be a constant, so I'm just going to call it c. Then as we're solving, now we're going to move this 2 to my exponent, so that becomes natural log of y squared equals natural log x squared plus 4 plus c. We're going to use the little e trick again. Cancel y squared equals cancel x squared plus 4, and then e to the c. Last step, to get y by itself, we square root it, so y equals e to this. So when I square root this, e to the c is just going to be a constant. If I square root this, we get square root x squared plus 4. So we end up with the exact same equation. Let's look at another example, and this time we're going to find a particular solution. So I want, given the initial condition y of 0 equals 1, so that is the point 0, 1, we want to find the particular solution of this equation. So we want to move this to the other side first because we want to separate our parts. We need x's with x, y with y. So we're going to write this as e to the negative x squared y squared minus 1 dy equals negative, because we're moving it to the other side, xy dx. I'm going to move this e to the negative x squared by dividing both sides. Those cancel here, and we get y squared minus 1 dy equals negative x. This negative in the exponent means I'm going to take this whole thing and move it up to the top. Okay, now we want to go ahead and finish getting all the y's on one side, so I'm going to divide by y. Oops, I wrote dy twice. Divide by y, and we get y squared minus 1 over y dy equals negative x e to the x squared dx. Okay, I'm going to use the calculator to do this quicker. We're going to use the calculator to get those two integrals. We're going to integrate both sides to get rid of the dy and the dx. So I'm going to type each one in. Try to move my calculator over a little. So menu, calculus, integral, we have y squared minus 1 over y, and this is with respect to y. So there's my left side. So I write 1/2 y squared minus natural log absolute value y equals, and then we're going to do the right side, menu, calculus, integral, negative x e to the x squared dx. And we get negative 1/2 e to the x squared, and don't forget your plus c at the end. I'm going to go ahead and get rid of the fraction now. I'm just going to multiply everything by 2. Two times c is just going to give me c still. Now I want to, what do we want to do? We want to use our initial condition. So our initial condition, remember back at the top there, was the point 0, 1. 0 is my x, 1 is my y. So I'm going to take this initial condition and plug it in to find out what c is. So 1 squared minus 2 times natural log absolute value 1 equals negative e to the 0 squared plus c. This whole thing here is 1 equals e to the 0 is negative 1. Add 1 and we get 2 equals c. So in the end, my final solution is this equation, but we're going to replace c with the number 2. So our equation is y squared minus 2 natural log absolute value y. I'm going to move the e to the x squared to the other side, so plus e to the x squared equals c. And there's my final answer. For the last example here, we're going to go ahead and use what we just learned on a word problem. Sorry, losing my words here. All right, so the rate of change, the number of coyotes, N of t, in a population is directly proportional to 650 minus NT, where t is the time in years. When t equals 0, the population is 300. When t equals 2, the population was 500. Find the population when t equals 3. So let's start off here, and with the fact that it says that it is directly proportional. So what this means is dn dt equals 650 minus n. And then don't forget your k. Directly proportional means we have a rate k. All right, so we are going to move dt to the other side, so we get dn equals 650 minus n k dt, and then we want to move the 650 minus n to the other side, so we get dn over 650 minus n equals k dt. Now when we take the integral of this, we end up getting negative natural log absolute value of 650 minus n equals kt plus c. I'm going to get rid of the negative by multiplying both sides by -1. Then we're going to use our little trick with e. So we end up getting 650 minus n equals e to the negative kt times e to the negative c. This part here is a constant, so this is our new c value. So we get 650 minus n equals c e to the negative kt. Now we're going to use our initial condition where it said for t equals 0, n equals 300. And this is so we can find out what c is. So 650, I don't know how that turned into 655. 650 minus n, which is 300, equals c e to the negative k times 0. K times 0 goes away, and e to the 0 is 1, so that's gone. So c is just the subtraction of these two, which is negative 350. So our equation is n equals 650, remove the 650 over, minus 350 e to the negative kt. Now we're going to use the second condition they told us, which was for t equals 2, n is 500. And we're going to use this to find our rate. So 500 equals 650 minus 350 e to the negative k times 2. You can use the algebra solver on your calculator to solve this. When you do, we get that k equals 0.4236. So the new equation is n equals 650 minus 350 e to the negative 0.4236 t. The last part of this question asks, when t equals 3, what is the population of the coyotes? So we're going to plug in a 3 here. So then we get n equals 650 minus 350e, negative 0.4236 times 3. We type that into our calculator, and we're going to round it up to the nearest coyote, which will give us 552. On your homework, it's a little bit more simple because I give you less, it's less steps because I tell you what K is, so you don't have to try to find K yourself. That's all I have, and we are done.